Let's give a minute more. Everyone needs to get back here. All right, guys. So I sent all these videos. I have already sent them to Amir sir. Hopefully, he'll post all those videos soon to you. All I have to do is add this particular video, whatever we are discussing today. That particular thing also we have to add to the list. So I think I have totally around 14 videos. I did not edit them. So whatever crap once in a while that was happening, even that will be part of it. Later, when I find time, I want to make more detailed videos out of these, like individual videos addressing each topic. So this is based on directly from the Zoom, whatever recordings I got. So still I have given names to those like electric current, chemical force, or working of a battery. Like that, I have given specific names. So whenever you want to revise, you can directly click on that particular video. Okay, so I'll be sending this one to Ami sir very soon, hopefully after the class immediately. Now, before we start with the leftover topics, very simple, 5 minutes or something will be done with all of that. So, what we need to decide is about electromagnetism. So, electromagnetism is much more fun than electricity. You'll be seeing all those magnetic lines of force. You'll be moving of wires when we bring a magnet and when we supply current in a wire. So, you'll see the movement of that wire. Those are foundations of electric motor. Then you can also see, I mean, I have built an apparatus where an aluminum ring floats in air. That's part of your syllabus. An aluminum ring levitates, it actually jumps out of the apparatus. So that's the basis for bullet trains. You are familiar with bullet trains, I hope. So what happens with bullet trains is they actually jump. I mean, they don't. I mean, the reason bullet trains are that fast is they don't have ground friction. So imagine this is the track. The entire train floats on that particular track, a little bit to the height. So since it floats and travels, there is no ground friction. All it has is air friction. And to reduce that air friction, they have that shape of a bullet, like the way it's curved in, like the lavish cars that you see on roads. They're very good, the streamlined cars. Similarly, bullet trains. So the foundation principles of bullet trains, I have an apparatus, we can use all that. So all this can be done once your syllabus is completed or once your electromagnetism chapter is done. So can one of you tell me, is it done already? Electromagnetism, is it done or is it going on right now?
Going on, sir.
So where are you right now yet? What topic specifically is happening right now?
Force on current carrying conductor.
Force on a current can. Okay, so Oysters experiment and circular coil solenoid, all that is done. Oh, that's good. So I think you're almost halfway there in that chapter. Once you're done with that, there'll be electric motor, and after that, induction topic. Induction is really interesting, much more interesting than the regular electromagnetism. So maybe we'll plan. I'll speak to Amit sir, and if he is interested, and more than that, if you all are interested, we'll have a class. Otherwise, this would be it. Okay, we will not be meeting again. This would be our last 10 minutes or so. It all depends on what you both decide. Okay. Now let's check out last couple of slides. All right. So I just want to talk about what happens throughout the power distribution way actually. So please check it out. It's This is the power station, and in the power station it could be various methods. It could be as efficient as a nuclear power plant, or it could be a hydroelectric power plant, or it could be a dam where just the movement of water, the potential energy supplied by the water turns the turbines and you could get electricity out of it. Okay, so something like that would happen. It could be any source actually. From that particular power plant, what happens is it goes to one of the substations. Okay, So at these substations undone. By the way, what generally happens is at this particular point, you can imagine it to be something like, let's say, 10 kilowatts or 1000, so 10 kilovolts of energy, or yeah, something like this, 10 kilovolts of potential difference, or the voltage could be there with that particular electrical power or electrical energy. So what these particular transformers do at this particular location, they increase that, actually they increase quite drastically. They change it to either 750 kilovolts volts, or maybe as low as 100 kilovolts. So it could be anywhere between 100 kV. So essentially, voltages are increased, as you can see. 100 kV to maybe around 750 kV is also possible. It depends on how good of transformers are used over there. It's one of the substations. So the reason they do is, if you directly send this particular voltage, the 10 kV voltage, and the electrical energy consists of not only volts, it also has amperes, electric current also. So electric current will also be enormous over here. So electric current will be huge. So electrons are moving very fast. If you have such fast moving electrons in these wires, lot of heat will be developed, and because of that heat, lot of energy wastages, efficiency of the entire system breakdowns, and you whatever energy you get is very little or high cost. So what they do is they increase this voltage like this using transformers. They increase the voltage, and when you do that, automatically the electric current becomes very, very small. That means the electrons move extremely slow, so the heat losses will reduce. So that's what happens, and these particular things. So whenever you see huge, huge things, something like this, what this resemble is very high voltages, 750 kilovolts. Maybe if you do not see such huge towers, maybe smaller towers, it could be like 100 kilovolts. So they want so 750 kilovolts wires to be as far away from the ground as possible. That's why they construct huge towers for 750 kilovolts. So now before it reaches home, all the 750 kilovolts or 100 kilovolts, they reach another transformer. It's at the neighborhood near our houses. So you can call it another substation if you may. So this entire 750 kilovolts or 100 kilovolts, whatever, gets converted to 220 volts. So it's very, very small, and the possibility of electric current increases a lot. So it's okay. The reason is 220 volts is relatively safe, and whatever our houses get out of it is pretty much comfortable. And all our instruments in our houses, could be fans, fridges, televisions, they need a little bit more current. So this particular reduction here, what we are doing is, it's called a step up transformer, where 10 kilovolts is converted to 100 kilovolts. And here we call it a step down. 100 kilovolts is converted to 220 volts. So there is a reduction here. Here there's an increase here. That's why we use the word step down and step up. And that particular thing goes into our houses, and it helps us have a comfortable life. So that's what is the entire energy grid. So I just want you to know about energy grid and all that systems. So very briefly and all. So one last slide before we close. So this is from your textbook. So why are we using fuse and all? We had quite a bit of discussion about MCBs, the mechanism of MCB, miniature circuit breaker. Okay, so that's the latest one. But previously everyone used to use fuse. So the purpose of fuse we need to understand. Now, everything in our house is connected parallelly. So one, we call it as a live wire. For example, we can call this one as a live wire, and this one as a neutral wire. So actually, when right from the, the substation, the transformer that's outside our building, it actually sends out two wires into our houses. One is called a live wire, which actually carries electric current to all our appliances, and another one is called a neutral wire. It takes away electric current from all these appliances, like closing of a circuit. In DC, we have closing of a circuit, right? Something like that. One carries the current, one takes away the current. You can imagine like that. So one of these is the live wire, and another one is the neutral wire. So all these are connected parallel to the 240 volts. So this live wire and the neutral wire are, they have a potential difference of 240 volts. So everything has 240 volts here, because all of these are parallelly connected, and based on their electrical resistance. So if you're saying a fridge to have 8 ampere current, because it's based on its electrical resistance. It has relatively less resistance, you can think. So it's actually getting more current. So the bulb, that the specific bulb you are using, may have really high resistance, so low current. Voltages are the same. Please remember, guys, voltages are constant. So all we can know is, if resistance is high, electric current will be low. Okay. When voltages are not constant, you cannot have this comparison. It's much more complicated. Here everything is having 240 volts. So this one is having less resistance, so more current is flowing through, and this one is having more resistance, so less current is flowing through. So all in all, if you see the total current that you have right now, 4 plus 2 is 6. Okay. 6 plus 8 is 14. 14 plus 6 is 20. Heater is off. The switch for the heater is off. And imagine the wiring, the electrical wiring that your house has. Imagine it could only resist 20 amperes. Anything more than 20 amperes, this wiring could catch fire because of enormous heat that gets accumulated. And also these electrical components or electrical utilities could also be damaged. So what happens is, if you suddenly switch on this heater, there might be 3 amperes or more. So it would be like 23 amperes. And this wiring, the main wiring, should support 23 amperes of current. So all these things could get burnt. So that's why what people use is, they use this fuse. This fuse, as you remember, it's typically made with tin and lead. Tin and lead combination. Lead is a special material. It immediately melts. So when anything more than 20, that means as soon as you switch on the heater, more than 20 amperes tries to flow in there. And because of that high heat, this fuse wire completely melts, and there will be an opening of the circuit, and no current will flow into these wires or into the bulb or the fan. So everything gets protected. So that's the purpose of a fuse, guys. It's a very, I mean, what we were discussing is called overloading. 20 amperes is ideal, not ideal, is the maximum limit. If more than that enters, there'll be overloading and overheating, and everything gets melted. Okay. So that's with the last slide I have. So with that particular thing, we can actually stop this topic, and I'm ready to address any questions. If you have anyone, anything, please ask me. And Amir sir, are you available? Are you right now here? All right, so we don't have Amir sir here. In that case, we will be closing our session. We'll ourselves do it. So please let me know, guys, what do you think? I mean, is there anything you have? Any questions? Nothing? All right.
All right.
So let's do this. I want you to give your reviews to Sir Amir sir, and let him know if you are interested in observing those experiments related to electromagnetism. If you did not like our session still now, just let him know, and we'll not have the interaction further. As simple as that. No egos or anything. So, but be open, because you will be spending a lot of time on these classes, and if you are not doing it, I mean, full-fledged, if you don't dive into it full-fledged, it's waste of your time, guys. My time is not as valuable as your time. Yours is more valuable time. So use it wisely, inform him properly, and I will get the information from him. So with that, we can actually close this session. Anyone wants to talk anything? Anything? All right. So, okay, guys, see you again if possible. And goodbye. You have my number. Any questions you have, you can also address to me directly, or you can ask Amir sir, and we can have similar session to address questions even at a later stage. I'm open to that also. All right, so let's close this session. Bye, guys. See you. Thank you, Vishnu Priya. Yes, it's my last class. If you don't want anymore, it's up to you. As I told you, if you want to hear electromagnet, I mean, I just had a question from Amarnath. Is this your last class? Maybe yes, or maybe not. It depends on what you want in respect to electromagnetism. If you're happy with what you get and everything, then it's okay. Otherwise, if you want to see even the activities, then you just have to let Amir sir know. All right, thank you, Harshita. You can also, guys, speak if you want. I'm getting the chat windows. You can also speak up. That would also be good, right? All right. Okay, guys. Thank you. Thank you. I'm getting lots of messages right now. Thanks a lot. And try your best to revise this, watch these videos again, or at least watch them based on the topic that you're not comfortable with. Okay. And always you can get back with questions to me. All right. I'm closing this session. Thank you all. Goodbye. Have fun. Be good.